All, my name is Abdurrahman and welcome back to my YouTube channel. So guys, in this video, I am going to give the introduction to Support Vector Machines SVM, which is a type of deep learning algorithm which performs the supervised learning for the classifications or regression of the data groups. So guys, in this video, I am going to give the introduction to SVM, like I will be talking about how it works, why it is used, and I am going to talk about it in detail. Okay, so guys, if you remember in the last video we have done the testing classifiers of the k-nearest neighbors, but guys, SVM, support vector machine, in this video, support vector machine is supervised learning for the classifications and it's used for the regressions also. So guys, I am going to talk about this in this video. And so guys, the objective of the support vector machine is to find the best splitting boundary between the data, between a group of dots or between the data points. So guys, in two-dimensional space, you can think of a best fit line that divides your data set. With a support vector machine, we are dealing in vector space. Thus, the separating line is actually separating the hyperplane. So guys, let's go ahead and get started. So guys, first of all, I am going to talk about why is support vector machine SVM is used. I am going to talk about that first of all. So guys, SVM, support vector machines, are used in applications like hardware recognition and detection, face detections, email classification, etc. And in web pages also it's used. So this is one of the reasons why we use the SVM, support vector machines, in machine learning. It can handle both classification and regression on linear and non-linear data, as I said before. Now guys, I am going to talk about the advantages of SVM. So guys, support vector machine works comparably well when there is an understandable margin of disclosure between the classes. And it's more productive in high dimensional spaces. It is effective in instances where the number of dimensions is larger than the number of specimens. Now guys, first of all, I am going to talk about how it's going to work with an example of a data set. Like I am going to use the same data group where I have used in the few videos before. Now I am going to show you a data set. So I have already used a previous example of a data set, like where I have given a group of dots, group of positives and group of negatives. Okay, so guys, let's see on the screen. Here we have a data set where we have some positives and some negatives, and with that here we have a hyperplane line, best fit line, good say. So guys, in support vector machine, how do we actually figure out that best fit dividing hyperplane? So guys, this is a hyperplane line that we have drawn. Okay, and guys, how do we actually figure out that this is the best fit dividing hyperplane? So guys, this is how we have drawn a line, right? So I'm going to show you that how we can do that one. Now guys, as you can see here on the screen here, I'm going to draw a line here. Okay, we can find the distance between these two, between a hyperplane line and here also like this also, and then we can find the distance something like this, right? So this is also a way that we can draw a hyperplane line. Now so guys, we can have another separating hyperplane, right? So guys, it can be something around like this, right? So guys, it would be like this, but here if I see the distance between these two, so guys, there is a smaller difference. There is a small distance between these two lines. So guys, the support vector machine, what it says is this is the separating hyperplane line, because the distance is very small here. So guys, it has a minimum of some distance, right? Now so guys, what I'm going to do is, so instead of this one, wait, okay, now at some point here we can create a data point here somewhere around here, right? So guys, I'm going to explain you this support vector machines with I'm going to implement this with the Python right now. Now so guys, as you can see here on the screen, here I have already opened the Jupyter notebook. So guys, if you remember some videos before, we have done the classification with the scikit-learn in the k-nearest neighbors at the time. Alright, so guys, so I have duplicated that file here only, and I have copied that file, and here I am going to use the same file. Right now we have to make some changes in this file and run it. So guys, first of all, here we have the neighbors. We don't need it, and so let's keep it, and I'm going to import here the SVM, which is support vector machine. SVM, guys, here if you see we have from the sklearn we are importing the pre-processing, we are importing the neighbors, we are importing SVM. But guys, if you see here, anywhere we are importing here the cross-validation. So guys, here we didn't import it that at the time because here we are getting some errors for using the cross-validation in the in the new versions. So here we have the new versions of this Python and other one. So that's why we are getting some error on this SVM. Right now, so that's why I have imported the train test split instead of the cross validation. Now let's run the first one, and this just run now. Guys, if you see here in the we have all of these all of the things same here. We have the neighbors here, right? We have the CLF classifier equals to neighbors dot k nearest k neighbors classifier, right? So guys, we don't need this. Instead of this, what I want is I want a SVM. Okay, so here we are doing something like svm dot svc support vector classifier, and then just here the brackets. All of the things are the same. Now we have these things. We have the numpy array. We have the predictions. All of these things right now. Now guys, I am going to run it, and now let's check whether what is the output that we are getting. So guys, as you can see here, we are getting it around the 67%. But guys, still we are getting one more error here. Now, so guys, as you can see here on the screen, here we are not getting any errors. So guys, the error that we are getting here was because if you see here, if you in this line, example measure equals to numpy array, and here we have given a parenthesis, and then it's good. Then we have used only one parenthesis. We didn't give this one at the end of this one. So guys, here we have to add this one, and then here we have to add this one. So guys, that's why we are getting some errors. Now, if I rerun it, I am not going to get any errors, and the accuracy is around 62%. Now guys, what if we give something like, if I remove this, what if we don't drop this one, and I want to, sorry, I want to do the, this one. Okay, so anyhow guys, now I am going to make this in this one, in the multi-line command, and now let's run it and check whether what is the output. So guys, as you can see here on the screen, here you want accuracy only. So guys, let's leave this one. So guys, let's see here on the screen itself. So here we are getting around 68%. So guys, there is not but that much difference, but here we are getting a minor difference. Okay, so guys, this is how we do the classification in the SVM support vector machine. So anyhow guys, that's all for this video. I hope you liked this video, enjoyed watching this video. Thank you for watching, and I will see you in the next tutorial. Thanks for watching. Thank you. Bye bye.